If you're going like I need we should check back. I think we have back online. Tell the people who are check.
Are you listening to the teacher?
Yeah.
I'm going to say something again.
Extension. Hello everyone. Please, sorry about that. Can you all hear me? Good evening. Yeah, good evening. Good evening, Chamaka. Obinna, you're welcome. Is it better now? Let me get your response before we continue. Is it better now? Kindly share the link to everywhere shareable so that others will be back. Okay. Okay, so Faith says it's better. All right, Chika. Okay. Okay. It's better now. All right. All right. Okay. Okay. So we can let every other person so that. Let me see. So it's not. All right. Okay, so can we start? Can we start? Is it good to start? Let me get your responses so that I will know. Okay, please respond if we should start. Oh, okay, let's now look at. I didn't hear your response. Let me check. Let me check. I'm just seeing it's better. The part of can we start? I've not heard what you said. Should I start? Can you hear what I'm saying? If you can hear, respond to the question. Can we start? Okay. Yeah, Clara says we should start. Okay. Okay, so um okay, so let's move over to let's check some questions on trigonometry. Let's look at some questions on trig. Okay, so that's under trig ratios. So let's look at problems on trig ratios and see some important exercises that I need you to see. Okay, so let me remove what we have here. Even though now we have a bigger view from the settings now. Okay, so we can use larger part of the board. Okay, so let's have something like this. Look at this example here. We are giving that I don't know which number, I think it should be number 3, but let me write it as 1 on this one. Now, this is a very common example or exercise that we work with. Now, the reason I'm showing it again is that, okay, so those are the things that we play around with when it comes to math 101, whether exam or whatever. Okay, so look at this. If it says if x and y are acute angles, x and y are acute angles. Okay, so acute, you know the meaning of acute. Okay, angles, and then such that sine of x is equal to 8/17, and cos of x, or cos of y, sorry, they say cos of y is equal to 12/13. So they are asking us to calculate in the sine of x minus y, and b the cos of x plus y. Okay, so these are the two questions we have there. And then there is another one they said there, Sha. So let me bring it in. Let me bring it as C. Or okay, also they said also show that cos x. Do I need to bring in this one? Okay, let me leave that one. Let me leave that one. Okay, so now you can be given this kind of problem, and what is this person expecting from you? This is a very straightforward, simple question. So this is expecting that you will use compound angles. I mentioned compound angles when we dealt with phi in class. Remember, I told you that when it comes to phi, that you're looking at basically maybe 2, 3, 4 things. Number one, trig ratios. That's the normal trig ratios. And then you are looking at the relationship, and under that relationship, we'll basically look at supplementary and complementary angles. And then after that, let me put that supplementary and complementary angles. Okay. Then after that, we will now consider what you can call the quadrants of angles, which is under relationship between angles, and then very importantly, your compound angles. So you look at compound angles, which is what we have here. So basically, these are just things that we are going to be looking at. Anything cannot go beyond these three ratios. The relation, you have your sine, cosine, tangent, you have the inverse trig ratios, and then their relationship. Like the second example we are going to see. So now, what do you do for this one? You should just know your relationship for compound angles, both for sine and for cosine. Especially, there's also for tan, but especially your sine and your cosine. And your sine states that if I have the sine of x, let me use okay the two signs, or let me use plus first. So if I have sine of x plus y, that this is equal to the sine of x. Now, sine alternates the trig ratios. So it goes with sine and cos. So this will be sine of x, cos of what? Y. Then another property of sine is that sine preserves the sign. Sine preserves the sign. Cosine alternates the sign. So you can use the name to remember it. Sine preserves this sign. So here will still be what? Plus. So you have plus sine, sorry, yeah, plus sine. Then what will now happen is that your y will now come over and then your x will go that way. So you will now have sine y cos what? Cos x. Okay. So that's the way sine works under compound angles. And that means if it was minus, or let me just use the one I've written already. So if it was minus here, so you will have minus, and so what will now be here will still be minus. Every other thing will be the same. Okay, so that's just for sine. While for cosine, to be good at stating now, for cosine, if it is plus, cosine is going to, now for cosine will retain the same sign two times. So you retain cos x, cos y. Then when it comes to sign, it does not preserve sign. So rather it change plus to minus and then bring in sine x, sine y. So that's the way cosine works. Okay? So now let's use that. So that's what you need to get the two solutions. So for this one, you are now going to have the sine. Okay, you have already gotten this. So now, because it's minus we are looking for, so now we will now try to substitute. So what is sine x? You already have sine x and you already have cos y, but you do not have sine y and cos x. So you will try to get that. So meanwhile, let's substitute the ones we have first. So we have 8 over 17 multiplied by cos y is 12 all over 13 and then minus. So what is going to be our sine y? From your sine x, you should be able to get sine y. How? Because, sorry, from your cos y, you should be able to get sine y. Don't mind me. Okay, so we have that cos y is equal to 12 over 13. And you know that cos is adjacent over hypotenuse. So that means your adjacent is 12 and your hypotenuse is what? 13. So if you make use of this, that will help you to get your which one sine that you're looking for. And what is your sine? Your sine of y is going to be opposite over hypotenuse. So that means you already know your hypotenuse as 13. So you're only looking for your opposite. But you know that by Pythagoras rule, I hope you are with me. If you have any question at any time, you can comment on the chat box. Somebody will respond to me if you have a question. All right. So by Pythagoras rule, we know that the square of h is equal to the square of o plus the square of a. And so square our h is 13 equal to o squared, that's what we are looking for, plus a squared, our a is 12. Okay, so now these are places where you will have to work things fast to get what you want. For instance, here you already know this is 169 and this is 144. So you just transform. 169 minus 144 is 25, and that is equal to o squared. So the square become over the square root of 25. So our o is what? 5. Now, even without solving all of this, once you see your a and this as 12 and 13, you should have known that your o will be 5 by constant practice. So you will bring your o here as 5. And so you are getting that sine y is 5 over 13. So we can bring that one here, 5 all over 13, multiplied by, then you need your cos x. You will do the same thing that we have done here. So permit me to remove this one. Okay, so what is our cos? So for you to get cos x, you will use sine x. Okay, so you bring down our sine x here. So sine x is, let me take it up where I have my cos. Okay, so my sine x is equal to 8 over 17. All right, so that means, remember, sine is O over H, and I'm looking for cosine. So what you need to do is 17 squared minus your O squared, and your O squared is 8 squared. That will give you A squared. I'm just using this formula now. If you take O to the other side, just so that your work will be faster. All right, because tomorrow is exam, so you have to do everything to be able to get to your result fast. So, but of course, nobody will ask you these two things at once. So we just ask only one, right? So all of these things I'm doing that will not even take you 1 minute. You just do it. You get my point now. Okay. So I know that because of some of you, the energy is gone, but just let's see. All right, so what is 17 squared? 17 squared should be around 389 if I'm correct. And then have to check that. And then 8 squared is 64. So equal to 8 squared. What? 2 what? 289. Okay, you see. All right. So 289. Okay, so when you subtract now, you are now going to get 225 as your a squared. And so a alone will be the square root of 225, which is what? 15. Okay, so that means our cost now, which is equal to a over 8 will now be 15 all over 17. Okay, so bring it here, 15 over 17. All right, and you are done. All right, you are done. You are practically done. All right, so then we move here now. So what do you do next? So you just simplify what you have. Now you can see that the denominators are the same, and that will form what we call like fractions. So all you need to do is just so your denominator is now 17 times 13, which is what? 17 times 13, and I write it there, 17 times 13. Of course, that's your common denominator. Why the numerator is 8 times 12 minus 5 times 15. What is 8 times 12? 8 times 10 is okay, 96. Yeah, 80 plus 16. So you have 96 minus 5 times 15 is 75, if I am correct. Yes. Okay. So then finally you will have this minus this is what? 21. All over 17 times 18. None of them can actually divide. I think so. Because if anything can divide 17 and divide this or 18 and divide it at all. So what's the multiplication? 2, 2, 1. Alright, so we have 221 as that's 21 over 221 as the solution. So like I said, nothing can divide 21 and divide 17 or 13. Therefore, nothing can divide 21 and 221. Don't bother yourself checking it. They won't divide. If they cannot divide the small, they can't divide the big one. Okay. So it's just like having something like 5 all over 2 times 3. Because nothing can divide 5 and 3, nothing can divide 2 and 3, nothing will divide 5 and 6. It's simple math, okay? So our final answer is 21, or sorry, 21 over 21. Alright? And it's the same process. So in the first one now, since we have already got all the sign S and Y cos S cos Y, so it's easy to substitute there to get the solution. Okay, maybe quickly let me go. Do that. Everybody try that one. Let's see. Okay, so what am I trying to okay, so why are we writing the also? Okay, so look at this. So what you can have something like 75 sine 2a all over 1 plus cos 2a. Okay, so and then they'll give you options. Now the question actually puts it this way, so that this is equal to tan a. Okay, so it asks us to show that this is equal to this. Alright, so now because this is an exam, if you are giving this kind of question, simplify this. and give the options, and then one of the options will of course be tan A. So okay, sorry, I give you an exercise. Sorry. Okay, I'm waiting. You say? Okay. Okay. What do you have? Do I have some responses? Check for me. How many responses? Anybody? I need for the second one, cos x plus y. What do you get? Hmm? Okay, no answer yet. Okay, I'm waiting because this class is supposed to be practice. So because tomorrow is the exam, so we are not just loading information. No, we need to practice and practice as well. All right. I'm waiting. Please help me be checking if there are responses there. Okay, should we do it together? That's the way we should be responding in this class because it's a class that needs speed. There is no time. So if there's anyone that you want us to do together, just say it so that we can move on to another one. Should we do it together? You let me know quickly. This is what we should do in 30 seconds or 1 minute. That's the expectation. Eh? Okay. All right. So did I get any comments yet? All right, no problem. So I want to propose that we should do that together. Those of you in the class, what do you have? Let me see. What do you have? 140 over 221. Okay. All right. So I'm going to divide, right? Okay. So some people in the class ask this. So those online, all right, let's check together if these are the same. Okay, so now give the cos. For cosine, compound angle of cosine is preserved. So cosine, then xy. Then you now have minus. So for cosine, plus goes to minus. For sine, plus goes to plus. And then the thing that alters in sine is the trig ratio. But the thing that alters in cosine is the sine of the compound angle. Is that okay? I'm saying this so that you master it. Okay. Did you get option responses? What do you have there? 142 over 221. Okay. How many? Just one, and then minus 21 over 221. Minus 21 over 221. Okay. All right. So let's do it together to confirm that. Okay. Who gave me the 1 minus 21? Okay, Mesoma. All right. So let's find out. Okay, so here we have this. So let's substitute. We already have the values here. So what did we get? Oh, I removed them. What did we get as cos x? I think we got cos x as 15 over 17. All right. And they gave us cos y as what? 12 over 13. Okay. While we they gave us sin x, right? Sin x as what? 8 over 17, yes. And we got sin y as 5 over 13. Beautiful. Okay. So that's the same thing If you take LCM, that's 17 times 13, which is 221. Of course, I'm happy that everybody got one in the denominator, so that one is okay. So here you now multiply this. 15 times 12 is 30 times 6. Somebody will say, how did I get that? Tomorrow's exam, there will be calculator, so you should be doing things like this. Okay, how did I get that? Because 12 is the same thing as 2 times 6. So I used the 2 to multiply 15 and it gave me 30. Because it's easier to multiply something that has them than these other ones that are like this. So that's why it's better to move it to this one. And so from here, I can easily get 30 times 6 is what? 180. Without a calculator. So I have my 180 minus, this one is straightforward. 8 times 5 is what? 40. Alright? So it's very easy to see. 180 minus 40 is what? 140 all over 221, which is this one here. Okay, so let's check. But whenever something like this happens, and I know it's just maybe small error of multiplication or sign or whatever. So check where that error came, and then you'll be able to fix it. It's actually better to respond to questions like this because that's how you are able to know whether you are following or not. And even if you miss it, you'll be able to point out where the mistake came out. And if there's any question, then you let me know. Okay, so let's go back on to, I can remove this now. Okay, so let's go back to the next question that we should be looking at. And then, because it is exam, I'll just be showing you what to do. Now, because some of you were asking me question yesterday. I think the question was it yesterday or today? It was on, can I remember again? Yeah, yes, it was on radical equation, something like this. If I can remember, x into was it x plus 8, sorry, plus 9 plus 1. I have a good head, my head is really working. It doesn't take much to remember math problems that I've solved. This is why you should be solving math problems. Even the people that gave me the question, they can't remember it the way I just did. This was the question they gave me that I think it was yesterday or this morning. Okay, yeah. And I told them that for questions like this, you don't have to solve. Even though we later solve it, but of course the solving will give you a longer process. Because it's a multiple choice exam, all you need to do is test, is wisdom, use the testing method to test it. So what do? Just try to test with the options you have because they will give you options. And we tested, and in fact, I think the answer was the first option, option A or the C option, I can't remember, and it was -8. So if you just test it quickly, you will get it. So if you put -8 here, that will give you -8 plus 9, which is 1 plus 1. And then on this side, you get -8 times 2 is -16 plus 20. And that is √4. So √1 is 1 plus 1 is 2. And √4 is 2. So it's -8 that will give you equality. That's exactly what we are going to do here. So we are assuming remember I said that the question was given, show that this is equal to this. But if it is exact, what we'll do is we'll ask you to simplify and then we'll give you options. Maybe the options is tan A, maybe the second one is tan A, and then the third one you can see cos 2A, something like that, and so on and so forth. So what are you expected to do in my approach, since it is a multiple choice exam? We're going to do another example of this. I'm going to bring that. All you need to do, pick an angle of your choice. In fact, the one that will be that you can easily determine the sine and the cosine. And in that case, what should I pick here? 30. I pick my A as 30. If I multiply 30 by 2, I will get 60. And this is also 60. So it's easier for me to simplify that, and get my answer. Or Whatever, you can even pick 45. I think 45 is also very good because 45 and 2 is 90. Okay, that will work very perfectly well. So let's say we use 45. So what are you going to do? You put it here and get the answer, and then put it here and check which one will give you the same value. That's all, and your answer will emerge. So for instance, if I put 45 here, I'm going to get sine 90 all over 1 plus cos 90. Okay, and what is sine 90? Sine 90 is 0, Abi? Yeah, sine 90 is 0. So, and sorry, sine 90 is 1. Check it. Sine 90 is 1. You know how I know that? I've been teaching you things that will help you. I know that from complementary angles. Sorry, yeah, complementary angles. You remember that we are told that sine and cosine are complementary. And I know for sure that sine 0 is 1. So if sine 0 is 1, then the one that will give me 1 for sine is going to be, sorry, if cos 0 is 1, then the one that should give me 1 will now be 90 minus 0. Because we are told that the sine of 90 minus theta is equal to the cos of what? Theta. Okay, so if you put your theta at 0, then so what it means is that if you do 90 minus 0, you will get sine 90. So the implication is that sine 90 will be equal to cos 0. Okay, and since cos 0 is 1, so sine 90 should be 1. So this shouldn't really confuse you at all. Okay, all right. So that is, this is 1. So this one is going to be 0 then. And so if this is 0, so you have 1 over 1 is 1. Okay, and quickly, in fact, that one is just the easiest one to use. We know that by trig ratios, that the trig ratio that will give you 1 on 45 is tan. Straight up, you don't even need to stress yourself. Once you put it here, tan 45 is 1. So that means the whole of this is equal to tan what? A. Alright, so you have that it is equal to tan A. Okay, so we can therefore remove this, right? But then if you watch, so you will see this one will give you 1 over 2, which is 2 over 2. This one will give you 0 and all that. So it's only the second option that will give you 1. I hope you are with me. Please let me know if you are following, and you can make reactions there, some emojis, so that I will be sure that you are following. Look at another question that looks like it, and I will expect you to respond to it. He says that we should prove that 1 minus tan squared x all over 1 plus tan squared x is equal to cos 2x. So then I'm going to remove that truth now, and I'm going to remove it and then put this cos 2 as an option. Do you get the idea now? Okay, so depending on what you have, all you need to do, let's take it that your A is given as sine squared x, and then B is given as, let's say, cos 2x, and C is given as, let's say, tan 1 plus 2x. So, we'll just give you many options. So, substitution or test of the options will be a very fast way to do this. Some of these things, nobody really needs to show us this. You should be able to, wisely pick out all of this. All right. So this is how we can bring this in exam. Okay. And all you need to do is, like I said, pick an angle, and it is in your best interest to pick the simplest angle. For instance, we just said now that tan 45 is 1. So why not pick 45? So that you can get 1 here and go your way. Or you pick 30 or whatever else. Okay, for instance, let's pick 30. So if we pick 30 here, if I put my x as 30, I'm going to have 1 minus. The reason I'm putting 30 is that if I pick 1, it give me 0. And I don't want to get 0 up. Not as though getting 0 is bad, but I don't want to get 0. Okay, so then let's pick the one that will give us another number. Now, you know that squared x is the same thing. I mentioned this in class and every other time I teach. It's the same thing as tan x all squared. Am I correct? Yes. Okay. So that means that is going to give us tan 30 all squared. And our tan 30 is what? 1 over root 3. You should have all these things offhand. Please, maybe I should even mention some of them now. Maybe I should mention some of them, at least for the major angles. We know sine 30, sine 45, sine 60, what again? Sine 90, and 180 at least. But this one's 90. Okay, in fact, let me just put sine here and then put the angles. Okay, so if we have 30, if we have 45, if we have 60, if we have 90, and then 0 too. Okay, so what am I drawing? Okay, so let's have sine here, and then let's have cos here, and let's have time at least these three. Okay, so you should be able to remember at least 1, 2, 3, 4, 5. These 5 special angles. So what is the tan sign of 0? I already said is 0 because the cos of 0 is 1. Okay, so what is the tan of 0? Is what? Undefined. Is infinity. And you know why it's undefined? The other showing you that no need. Okay, so now what is the sine of 30? What is sine of 45? 1 over 2. What is sine of 60? Root 3 over 2. What is sine of 90? 1. You get the point? So all of these, you should just be able to keep that around them. What is the sine cos of 30? You just alternate. 30 and 60 is 90. So whatever sign got in 30, cos will get it in 60. And whatever sign gets in 60, cos will have it in 30. That's just it. Okay? So this one will be 3 over 2. This one, they have the same thing under 45 because 45 plus 45 is 90. So the answer will be the same here. So this one will be half, and this one will alternate here. Whatever sign has in 90, cos we have in 0. And whatever sign has in 0, cos we have in 90. So that means here will be 0 and here will be 1. That's all. Okay. So when you have a job in other time, which is still not a job, what is that of this? 1 over root 3. Under the one of time, that is alternating itself. So when you go to, you already know 45 as 1. So when you now go to 60, time will alternate itself under 60 and 30. So that is 1 over 3 in 30, and in 60 it is what? 3 over 1, which is 3. Okay, so that's just it. Then under 90, what is it? What's stand in 90? Okay, now you know what you like I said, you always used to remember that is look at this. You know where this is coming from, it's right angle triangle. This is a hypotenuse. Let's assume that this is the theta angle. Okay, okay, and then let's assume that if here is theta, then here is opposite and here is adjacent. You know that tangent is opposite over adjacent, like we said before. So now, if you are referring to angle 90, okay, let's take it that here is 60 and here is 30. So that means here is 90. So if you are referring to angle 90, I want us to see the value of this. So you see that for angle 90, Remember, you're looking for tan, opposite over adjacent. For angle 90, your opposite will be the hypotenuse. The side facing angle 90 will be the hypotenuse. So you have H. Why your adjacent? Now, your adjacent is now confused. So he does not know which value to take. Okay, so he doesn't know which value to take here. So that's why that 90 is actually on the value because you don't know the value. So is it this side that should be the adjacent or this side? So that's why 90 is on the value. So this is actually the undefined one. So this guy is not. That's why this is beautiful. You always know which one is which. So there, zero. Check for me. That zero should be zero actually. Let's be sure. Yeah. So that zero is zero. So it is the 90 that is undefined, not this one. So you see, this place is undefined, and so the value will be undefined. Okay, so this, if you know this one, you are good to go for 3 tomorrow. You are good to go for 3. So just know this basic one, and then know your complementary or supplementary relationship, know your compound angles, at least for sine and cosine, and then you are able to now do all the. They give you this big thing, you think it's big. No, just the substitution approach, and you get your answer. So like what we are doing here, if we put 30 now, so we have 1 over root 3. So we have 1 over root 3 all squared. Then all over the same thing will happen here, plus 1 over root 3 all squared. So see what will happen. Now, of course, I'm going to get 1 minus 1 squared is 1, and 3 squared is 3. The roots will cancel the square. All over the same thing will happen below. So here you are having 1 minus 1 over 3 is 2 over 3. All over 1 plus 1 over 3 is 4 over 3. So you will discover that the denominators will cancel. So you just have 2 over 4. Or you can just turn it by yourself. So this should give you 2 over 3 division. If you change division to multiplication, this fraction will turn over. So you have 3 over 4. I'm just showing you easy ways to do all these things. So instead of doing this, just know what the denominators are the same. Cancel them out. Just divide your numerators. Do I have any question there? Okay. Some persons are not following. What's happening? Why are you not following? Let me see. I have excellent. What is this? Okay, it's lagging. There is an excellent network. Why is it lagging? Okay. Say stream is healthy. So why is it lagging in your own? Maybe your network is bad. It's cracking. Great one. Okay. Now you dey type this. Okay. Sorry. Maybe your network is why it's lagging. It's actually having excellent connection from my end. Can you check your network? I cannot connect to this network. Did you choose 30 as X or was it given? I chose 30 as X. I'm the one that, remember we said we are doing testing approach here. You are the one that will choose any angle of your choice. Okay? Yeah. What's the name of the person? Dave. Okay, Dave. Yeah. I was the one who chose, and like I said, you can choose any angle of your choice. You can choose 45. It will be easier actually with 45. Don't mind what I'm doing here. You know, it's taking your time. 45 will make it a lot easier. So, but I just said let's do it with this. Okay, don't worry, we'll still do it with 45 so that we'll see what I'm saying. But I'm the one that chose the angle. It was not given now. So you are just trying to put, see what I'm trying to do. I'm trying to put the angle here. See, okay, see where we are. And check what it will give me. And then put it in the options. and see which one will give me the closest, the same answer with this one. So the best thing is to use the easiest one, and 45 will be the easiest one. So, but since we have started this, let's finish it off. So if you put, if you now cancel out here, so you just have, of course, 2 here is 1, 2 here is 2. That will give you 1/2. Okay, so now that we have gotten 1/2, so you will now substitute the same 30 you chose in all these options and see the one that will still give you 1/2. Okay, and of course, if you put it here, if you put 30 here, you are going to get sine of 30 all squared. Okay, and sine of 30 is we said is √3/2. Sorry, it's half. Okay, so if you square it, you get 1/4, which is not this. So that means it is not option A. So you go to option B. If you put 30 there, you have cos 2 times 30. Okay, because this is 2x. So 2 times 30 is 60. So you have cos 60, and cos 60 is equal to half. So that means the second option is the correct answer. Okay, so that's what we are doing, just testing. So use testing a lot when it comes to trigonometry to help you. Okay, like I said, you can test one. If you test one, you see that it will work. Okay, all right. So, all right. Thank you. That's beautiful. That's beautiful. Okay, all right. Um. Ooh. Okay, look at this one. Let me give you this one, and then let me see what you have. Let me call it number 4. Okay, so here you have simplify cos 2a minus 1 all over cos 2a plus 1. Look at my options. My options are A, tan 2a, B minus tan squared a, C sine squared a. Let me put D. D is the, let's say, minus cos, okay, cos a all squared, which is still the same thing as cos 2 squared a. Okay, so check it. Which one will be the correct answer for that? Yeah, TJ says that sign is √2. Is that me typing that? Okay. Okay. Okay, yeah, okay. Kamsi, is that C the answer to the question, or let me know? Okay. What do you have? Did you get anything? Okay, somebody says C. Let's look at it. Any other person? Somebody said what? B. Which one is B? Is it B or B? Okay, B. Okay. Okay. So of course, I'm aware that the broadcast is lagging, so you may not be hearing me at the same time when I said it. That's not a problem. Okay, so but we should try to increase it. All right. So if we check the book, the answer said show that this is equal to B. So I think B is correct. Okay, for the person that gave B, that is correct. Okay, so let's look at it. What option do you use? Now, using A as maybe something that will give you 1. So which cost will give you 1? That's 0. So with 0 work, okay, let's leave 0. Okay, we get 1, that will lead us to 0/0, which is actually okay. No, we still make this one correct. So let's leave 0. You see why I said sometimes 0 will not be a very good option to use. So let's check cos cos what now? What should we use our A as? The person that got B, what did we use A as? Let me see, what's the name? Bright. Right. What did you use A as? Eh? Okay, cosine. What did you use A as? Let me see. Okay. Any response yet? So if we use A as oh, okay, what did we get cos 90 as? 45. Okay, 45. Okay, 45. Okay, let's use 45. Okay, so let's use 45. So if we put in 45, that will give us cos 90 minus 1 all over cos 90 plus 1. I think that's nice. Cos 90 gives 0. Okay, and so you will have 0 minus 1 all over 0 plus 1, which is minus 1 over 1, and that's minus 1. Okay, and that's straightforward. It's straightforward. You get minus 1 here. If you put 90, sorry, 45 there, that will give you tan 90. That's for A. And so A and 90 is infinity. That's A is not it. And then B, if you put minus tan, now remember that tan squared, I'll keep saying this. Tan squared means tan A or all squared. So that's A all squared, which is equal to minus tan 45 all squared. And tan 45 is 1. 1 squared is still what? 1. So you get minus 1. So that means B is correct. Okay? Alright. So that gives you a correct option. So you see, this will always make you faster in getting your solution, especially because this is a multiple choice exam. So you don't need to put yourself through many stress situations. Okay, now I let's look at. I have some nice questions here that I want you to see. That just so you know, we just finished inequalities. So, but I just saw these nice, beautiful ones. So let me see what you can do with it. Then, listen. What? Can you use 30? Okay, sure. You can use 30. 30 will give you correct answer. Yeah, you want us to try 30. Well, quickly, let's see if we can try 30 here. Very fast because of our time. So if we use 30, remember I think it was cos 2a, Abi? Okay, so if we use 30, that would be cos 60 minus 1 all over cos 60 plus 1. And that is going to give us 60 is half. That's a good option too. Beautiful. And half plus 1 as well. So if you put that, that would be minus half all over 1, sorry, all over 3 over 2. Okay? And like I said, 2, the denominators are the same, they will cancel out. So you just have minus 1 over 3. Okay? So you just substitute. And if you put 30 here, see what will happen. You will have, I'm putting it straight to B immediately because of time. So if you put it there, you have minus tan 30 all squared. And tan 30 is, like we said here, 1 over root 3 all squared. So immediately you will have minus square of 1 is 1, square of root 3 is 3. So it will definitely give you the same solution. Okay, and so B is also correct. So 30 will do that. Any angle. Now the reason why I'm saying you should choose is that you should choose the one that will make the work much easier for you. Okay, look at this other question that I said to show you under inequalities. Let me call it, I don't know the number again, maybe 5. Okay, so can we look at this? 1 over x plus 3 less than 2. Okay, just look at it fast. Then the other one, you have 2y minus 1 less than or equal to 3, and 2 minus y less than or equal to 5. Okay, so here you have two inequalities and you are asked to solve. So what do you think that would be? Answers for the first one, everybody. Everyone, everywhere. Okay. Aha. Good. This one is not supposed to take time now. Any answer? Yeah? say? You said? Then I think in the end, the two solutions should join together. When you finish solving, you should join the solutions. X is greater than minus. For which one? That person, X is less than minus 5. For which one? Okay, for number 5, that's what we have there. Okay, yeah. Okay. Okay. Okay, we are together. All right. So what do we do then? For the first one, just cross multiply now, Abby. It's just like a fraction. Remember the first one we did, I said clear the fraction. So it's just like a fraction, you're clearing it. And that means you're multiplying both sides by x plus 3. Or you can just call it cross multiplication. You know, so now those are two ways you can see it. So if you multiply both sides by x plus 3, it will cancel this side. You have only 1 less than the other side will now be 2 times x plus 3. So which is the same thing as cross multiplication. Okay. So and of course I know from here you should be able to finish up. So this is going to be 2x plus 6. Okay, and this one can come over. So 1 minus 6 will give us minus 5 is less than 2x. And so we divide both sides by 2. Okay, so our x alone, let me see right the way it is. So minus 5 over 2 is less than what? X. Or you can turn it over that way as x is greater than minus 5 over 2. But you know you can write this outside the interval form. What will you do? So in interval form, what is it going to be? So remember I told you that we will always put this in interval form. So it's less than this means that your x is greater. So that means the lowest point is this side, and then your x continues to infinity. So that means since it is less than, simply less than, you will use an open bracket. So you will have minus 5 over 2, comma. So you starting from there and then to positive infinity. And so you put positive infinity here. And whenever you have infinity, you should always use what? Open bracket. All right, open bracket. Okay, so that's this and this are the same. That's what I'm trying to say. Two of them are the same. Okay, so that's for number 5. So for the 6th one, what are you expected to do there? So all you need to do, meanwhile, okay, let's not bother. When it comes to equality, there's no point testing. Testing will not be faster for you. So it's just good to solve it fast and get your answer. Okay, so for number 2, is the best thing is to solve. After solving, you're expected to join your solutions together. Okay, so look at there. I have 2y minus 1 is less than or equal to 3. I hope you are following. Please remember to send in any comments. All right. Okay, so for the person that said I should solve it, I hope you followed. Okay, and I hope by now our network is more stable. Okay, so we have this and we have the other one. Let's put the two of them together and be solving concurrently. Okay, so now I'll be doing this, I'll be doing this at the same time. Okay, so what do you do here? Take minus 1 to this side. You have 2 is less, 2y is less than equal to 3 plus 1, which is 4. On this side, and your y is negative. So you need it to be positive. So take it this way and take 5 this way. So I'll have 2. 5 coming over here will be minus 5. So I'll have less or equal to 1, minus 5 coming over here will be plus 1. And so here, God by divide both sides by 2. My y alone is less than or equal to 4 over 2, which is 2. You are getting the answer for this. Y here you have minus 3 is less or equal to 5. Sorry, less or equal to y. And you have also gotten the answer for this. So, which is beautiful. And you can see, as beautiful as it is, the signs are facing the same way. The sides are facing the same direction. So you just join it. How do you join it? This one that is starting with should now come this way. So my answer is now minus 3 is less than or equal to y, and the same y is less than or equal to 2. And you are done. Minus 3 less than 1. Okay, no equal to. Okay. Sorry about that. The equal to sign is there, and if you throw it away, okay, maybe it's not in your own phone to press equal to. Then you can get it by holding that less than. If you press it and hold it, equal to sign will come out. Okay, just to teach you that one. You will pay for teaching you that. Alright. So if you put this in interval form, what is it going to be? That will be close minus 3 and what? Close to. Okay. All right. So that is it. Okay. So that's what we got there. Nothing serious. Okay. So we are picking majority of the topics, and then we are checking the different ways that questions can come from these areas and how to tackle them straight off. Okay, now let me review again for us. Do I need to give you another question on this? No, I don't. Okay, under complex algebra of complex numbers. You remember that guy, Abi? What was there? Why shouting? What was there? Yeah? Okay. So what is there? Yes. Okay. So algebra of complex numbers. Okay, but even before then, let's look at this question on binomial theorems. I'm trying to pick out those areas that will be of issues to us tomorrow. Binomial theorems. Okay, let me see. It's not as though, okay, so let me conjecture something. Okay, let's assume we have, I'm calling this one 7 now, I don't know the number I have with me. Okay, let's take it that we have something like maybe the bracket of, say, x minus maybe 1 over 2 raised to the power of 11, and you are asked to find the, let's say, the 6th term. For instance, find the 6th term. Meanwhile, I would always say, when it comes to every topic, you should be able to know what is questionable there. Okay, so like under binomial theory, we can ask you to find a particular term. We can ask you to get a number or the term that is independent of x, and so on and so forth. Okay, so those are the two major things that will be asked you, and then there are other ways we can also frame questions. For instance, this one, how do you get the physics term of this? Okay, so you recall I have always said in class that for the number of terms in a particular binomial expansion, then you don't need to do the expansion to get, that's the complete expansion to get the number of terms you are looking for. You can use the theorem to be able to do that. So I expect you to solve it now and maybe give me an answer. Okay. Do you have any question then?
Normally say number 6 is -3.
Okay, thank you. Yeah, 6 is -3 to close brackets for the two of them. All right. So for number 7, what do you think? The sixth term of that expansion, if it is done. Okay, so remember our formula, right? If you have x plus y raised to the power n, always remember that formula for combination to help you very well. That's where you have n 0, or let's say nr multiplying x to the power of n minus r times y to the power of r. Okay, where your r must start from 0 upward, right? So your r will always start from 0. Okay, so with that you should be able to know. Okay, so now that means my sixth term is going to be the r is the thing you need to determine. So you need to find your r. Once you get your r, already you know your n. In this case, our n is 11. So just get your r, substitute here, you will get every other thing. So what is our r for sixth term? That will be what? 5. Because r will start from 0. So it's going to be 0, 1, 2, 3, 4, 5. That's 1, 2, 3, 4, 5, 6. So the sixth term, we have the r as 5. Okay, and that's going to be, so we now substitute here. So that will be L is 11, R is 5, into the bracket of x raised to the power of 11 minus 5, which is 6, multiplied by our y is -1/2, not just 1/2. I hope you know how that is gotten. Okay, because if you check the formula, it is x plus y. So that means the sign that should be between the two should be plus. And you know that if you write x minus half and bring in plus sign, it's going to be x plus minus half. Because you know plus minus is what? Minus. Okay, so that is very important. Okay, so that means your x is the first term, your minus half is the second term, not only half. Some of you will pick only half, and that will be an error. So here we have minus half to the power of to the power of your r, which is 5. Okay, so that's all. So you just simplify. So what is this? This is going to be a little bit big. 11 factorial all over 11 minus 5, which is 6 factorial times 5 factorial. Am I correct? Yes, that's combination. Then times 6 raised to the power, sorry, x raised to the power of 6, and then this one, since the power is odd, then the half, the minus, sorry, will remain. So we can bring it out here. So we can bring out the minus here, since the power is odd. Then if the power is even, this minus will disappear. Are we getting what I'm saying? Yeah. Okay. So you can now open that bracket, and that will give you 1 raised to the power of 5 is 1, 2 raised to the power of 5 is 32. Okay. So remember, this is over 1. So you can now simplify your factorials. So if you do the simplification, whatever you get will be your solution. Did we simplify that? What do we get?
Minus 231 x
Minus 231
x to the power 6.
x to the power of 6 over 16. Okay. All right. So we've been able to cancel out. Of course, if you expand it, you can cancel out where necessary. Okay. So this is what you have. All right. Okay. So and that is your sixth term. That's our sixth term. Okay. So that's majorly what you will see when it comes to binomial theorem. Okay. We've touched trigonometry. We've touched inequalities. We've touched binomial theorem. Nothing more serious. Okay. So under complex multiple complex numbers, let's look at that again. So we just in that one we are going to only see maybe division or conjugate. Okay, let's just run a division on that. Okay, so number one is that a complex number is made up of a real number and an imaginary number. So the real number is your A, the imaginary number is the one that has I. So your BI is the imaginary number. Alright? So in other words, the real Z is your A and imaginary Z is your B. Okay? Alright. So all of this very important. Okay, now after knowing what a complex number looks like, the other thing you need to know is what we call conjugate of a complex number. So the conjugate of a complex number, it actually takes two forms. So one of the forms is it is either you change the sign in between to negative, and then or you can change the sign of this one. If I change the sign of A to negative and then this one, both of them will form conjugate. Am I correct? Yeah, both of them will form conjugate. What is the conjugate? One will multiply this to give you a number that doesn't have I. Okay, and if you do that, you will get conjugate. Yeah. Okay. So both of them will form conjugate. So but this is more preferred. So we use this more than this one. So let me remove the other one. Okay. All right. So now this is conjugate. Okay. So what it means is that the real part of the conjugate is A, and the imaginary part of the conjugate is minus B. Okay, all right. So now we can now go ahead and then begin to do addition, subtraction, multiplication, division. I'm not going to do those ones. To add is just to add the real to real, add the imaginary to imaginary. To subtract, the same thing. Subtract real, real, subtract imaginary, imaginary. Multiplication, open bracket, the same way we have been doing. So we just look at division. How do you divide? If I have Z1 all over Z2, we have also done this. All you need to do is to multiply both numerator and denominator by the conjugate of what? Z2. We multiply by the denominator, the conjugate of the denominator. Let's look at an example. So for instance, you have something like I plus, sorry, 1 plus 2I divided by, let's say, 2 minus I, something like this. Okay, so how do you do this division? You do it by multiplying both the numerator and the denominator by the conjugate of the denominator. So what is that going to be? So the conjugate of the denominator is 2 plus I. Am I correct? All right. So let's open the bracket. So you can see in doing this, we are going to do multiplication. That's why I didn't bother with that. So let's multiply now. Okay. So that is going to give us 1 times 2 is what? 2. 1 times I is what? I. Now we are done with 1. Come over to 2I. 2i times 2 is what? 4i, and 2i times I is 2i squared. Am I correct? Yes. And you know that I squared, somebody was asking that this morning. You know that I squared is equal to what? Minus 1. Okay. So all over. Now, when it comes to multiplication of conjugate, don't bother yourself opening the brackets like I did. Just take this and multiply this. That will give you 4. That's squared. Then minus square the other one, which is I squared. Okay? And that's enough. Okay. Right? So let me remove here. So that is going to give us what now? We are now going to have, now remember what I said here, you are going to have 2i plus 4i will be what? 5i. Then this is minus 1. So minus 1 times 2 will be what? Minus 2. All over. Here you now have 4. This will be minus, then I squared is minus 1. Am I following? Or is that correct? Yeah, okay. So see what will happen. This will take away this. So we just have 5i all over 4 minus minus is what? Plus. So 4 plus 1 will give us what? 5. And you are done. So your answer is just what? I. That is I, a complex number. Remember, we say the complex number is always of this form. Okay. So, and of course, I'm taking time to explain that. Yes, it's a complex number. Your A here is what? 0. And your B is what? 1. Okay. So, therefore, your answer for that is equal to what? Minus I. Okay, so I'm just going to give you this exercise to look at. And since I'm going to end the class here, which one? Which one is confusing? Who is the person? Dave. What's the second name?
Dave.
Okay, Chika have been giving me solution now. Which one is confusing? Is it the complex numbers? Let me hear you, Dave. Because when it comes to complex numbers, let me tell you, the major things that we will be expecting from us is conjugate of complex numbers, division of complex numbers, and writing complex numbers in polar form. I mentioned that even in class, writing complex numbers in polar form. Or basically, when we talk about polar form, we're actually asking you to get the length, that's the magnitude of the complex number, and the argument. Sorry, magnitude and argument are they the same? Okay. So we are asking you to get the magnitude and the argument of the complex number. Of course, we said that the argument is the theta, right? Yeah. While that's the angle the complex number makes with the horizontal axis, and then while the magnitude is the radius. Okay, the radius or the length or the absolute value of the complex number. Yeah.
It's more than the same.
Yes. Is it certain as well? Yes. So the modules, of course, the modules, this is what you call modules. So these are all like, that's what you call modules. Okay? So you either call it the modules, the length. I'm telling you about 4 names. So you either call it magnitude, modules, length, or ranges. Alright, of the complex number. Then you have the angular distance of the complex number, which is the argument. Okay, so and what is the modulus? The modulus is simply equal to a over b. Am I correct?
No, you.
Oh, sorry, yeah, B over A. Depending on the nature of what you have, your B over A is your modulus, while your argument.
No, sir, the modulus is
Wait, I'm coming. I'm coming. Okay, no, the argument that I'm talking about. So the argument is equal to tan theta, which is equal to, so your theta alone now. Remember the argument is that your theta, okay, and theta alone is equal to the tan inverse of B over A. Sorry, your modulus, which is, of course, those of you that did physics would have seen it under magnitude of a vector. So it's equal to the square root of A squared plus what? Plus B squared. Okay. So the square root of A squared plus B squared will give you the magnitude, while the tan inverse of B over A will give you your argument. Okay, so by the time you get the radius and you get the theta, so the polar form of your z is equal to your r comma your theta. So some people will write it this way, r comma theta. Some people will write it as r angle theta, something like this. So you can see something like 5, and then you see angle 30 degrees. Okay, so that's showing you that the radius of that complex number is 5, while the argument is 30. And there's most people represent it this way, r comma theta. Okay, so where r is the radius and your theta is the argument. But back to this division that Dave said is confusing. Has he said something else?
No. Just as somebody said, can you please touch polar from the complex number?
Okay, that's exactly what I have done. I think the person should respond now to whether he or she has gotten this. Okay, so when you have a complex number, for instance, let's look at the where the one we just did now. Yeah, let's say for example z1 equal to 1 plus 2i. So the radius, which is your r, is equal to the square root of 1 squared plus 2 squared, which is equal to the square root of what? 5. Am I correct? Yeah. Okay. And then, yeah, your argument, which is theta, will now be tan inverse of your b, which is 2, all over your a, which is what? 1. Okay, so by the time you take the tan inverse of 2, what will you get? Is it defined? Check it, check it. So that's why we may not necessarily give you polar. We may just ask you to get, or if we want you to do the arguments, we will give you values that you can easily get their tan inverse. Something like 1. Tan inverse of 1 is 45. Something like what are those ones that we did here? You know, we did 60, 30. We may give you something like this. Maybe z is equal to, let's say, 1 plus root 3i. Are you with me? So we may give you 1 plus root 3i, because we know that this is going to, your theta is going to be tan inverse of your b is root 3 all over 1. And we know that the tan inverse of root 3 over 1 is equal to what? 60 degrees. Okay? So now we can give you angles or values that are easily determinable. What you can easily get the angle without calculators. Alright? We may not give you things like 2. Okay, so another one is that we can give you something like z equal to root 3 plus I or minus I. For instance, we give you minus I. Okay, what is that going to be? That is going to, let me show you something beautiful here. So the argument here is going to be the tan inverse of your b is minus 1 all over root 3. Now see what tan inverse, sorry. Okay, so see what's going to happen there. You are going to discover that, I hope I'm not leaving anybody behind.
What's the part of binomial expansion where they ask us to find the term independent of x?
Okay, independent of x. Okay, no problem. All right, so let's finish up this. So what do you think will happen here? So you know that tan is an odd function. Am I correct? Are you aware? Okay, so you can check that. Only cosine is even. Tan and sine are odd. So all you need to do here is you can just bring out your since it's negative, or you can use quadrants of angles. Quadrants. Okay, so you have add sugar. Sorry, add sugar to coffee. Okay, so add sugar to coffee. So tan is positive here, negative here. Sorry, positive here. Negative in second quadrant, negative in third quadrant. Sorry, fourth quadrant. Okay, so that means if I get my tan inverse of 1/3, that will be 30. So I will need to get the equivalent of 30 in the second quadrant or in the fourth quadrant. And the equivalent of 30 in the second quadrant is 150. So that's going to give me my theta is equal to 150. All you needed to do is 180 minus 30 degrees. Okay? So, and that gets you to where you are going. Okay? All right? So the why do I get that? I first of all remove the minus and got the value of tan inverse of 1/3. Tan inverse of 1/3 is 30 because tan 30 is 1/3. Okay, but we are saying that when the tan was gotten, it gave minus 1/3. So we are now asking which quadrant will give you minus. So which quadrant is tan negative? So tan is negative in second and in the fourth quadrant. So how do you get the value of 30 in the second quadrant? Just do 180 minus the acute angle. How do you get it in the fourth quadrant? Do 360 minus the angle. How do you get it in the fourth quadrant? In the third quadrant? 180 plus. Okay, so yeah, so
It's less than 1. I don't know. Getting that.
okay, maybe we have passed that place. Please, if your video is lagging, drag it to the end, so that you will follow us, so that you will not be behind where we have passed. Okay, I think that this explanation is clear now. Yeah, okay. So if you have your calculators, you can check all of that to be sure that it's the same thing. Okay, now somebody is asking me to look at binomial theorem when you are asked to find the value or the term that is independent of x. Okay, even though I wanted to pause here. What's the time? What's the time? 11. Okay, okay. So all right. So we should continue again. That please, I'm confused. Why are you confused? I touched the part of binomial theorem. Okay. See, baby, say where you are confused. Let me hear. Please, can you write it down for us? Which one? Dave, which one should I write down? they add stuff. I said add sugar to coffee. Add sugar to coffee. Let me elaborate that. I think I do it now. Okay, I just remove it now. Add sugar to coffee. That's that's what they used to teach me since time. Okay, that's all. All three ratios are positive from 0 to between 0 to 90. Then add the sugar. Sugar means only sign is positive from 90 to below 180. You know, here is 180. And then 2 is tan. Tan is the only positive one between 180 and 270. And then coffee. Coffee is cosine. So only cosine is positive between or from 270 to 360. Of course, you know this is 0 and 360. Okay. So now that's what I was trying to say there. But if you bring back what I was explaining there, even if let's try it in the case of sine. For instance, if you bring sine 30, you will see that sine 30 will be equal to its equivalent in the second quadrant. And like I said, the equivalent in the second quadrant is 150. So if you check sine 150, the value will be the same. And the sign will still be positive because sine is the only positive one in the second quadrant. So, but if you check tan 30 and tan 150, the values will be the same. The only thing that will be different is their sign. The same thing applies to cos. If you check cos 30 and cos 150, the values will also be the same in terms of numbers, but only their signs will be different because these two are negative in the second quadrant. All right. So that sign is positive there. And when you go to the third quadrant, for instance, and like I said, how do you get the value of an angle in the second quadrant? Just do 180 minus that angle. How do you get the value of an angle in the third quadrant? Just do 180 plus that angle. So for example, if you are talking about 30 degrees now, the value of 30 or the guy that is similar to 30 in third quadrant is going to be 210. So if you press sine 210 now, it is going to give you, remember sine 30 is 0.5 and sine 150 will be 0.5. Sine 200 is still 210 is still going to be 0.5. But the only difference now is that 210 is in third quadrant. So it will now be what? Negative. And if you go to the fourth quadrant, the component, the one that is similar to 30 in the fourth quadrant is going to be 360 minus that angle, theta. So if you do 360 minus 30, that is 330 degrees. So 330 degrees, 210 degrees, 150 degrees, and 30 degrees will all have the same value if you check their sign. You check their sign, it will be 0.5, 0.5, all true. But this two will be positive, this two will be negative. You can be checking what I'm saying while I'm saying it. And the same thing happens for tan, and the same thing happens for cosine. If you check the cosine of 30, it will be 0.8660. If you check the cosine of 150, it will be 0.8660. Then because it is second quadrant, it will be negative. If you check the cosine of 210, it will be 0.8660. Then because it's in the third quadrant, it will also be negative. And if you also check the cosine of 380, it will be 0.8660. Then this one is in fourth quadrant, so it will be positive. So each of them have two positive and two negative. All right. So that's that for this. And what we use to activate it is add sugar to coffee, and we go like this: add sugar to coffee. Okay, so that's very important. So what you need to note here, and this is very important for this exam, what you need to note here is the 0 to 90 is theta, then second quadrant is 180 minus theta, third quadrant is 180 plus theta, fourth quadrant is 360 minus theta. There is no 270 anywhere. Don't bring in 270. It won't give you the correct thing. It is from theta to 180 and then to 360. Okay. So that is that for these quadrant angles. I said I was going to mention the quadrant angles, compound angles, supplementary and complementary angles, and trig ratios. That's all you need on that trig. Nothing serious. Okay. Now there was a place I talked about what do you call it? Division of complex numbers. I think that's where Chibibi and the rest said they were confused. Just try to do, and there's an example I wanted to write. Try to do it and then get back to me. Maybe something like this. Let's take it that we have 5 minus, or let's say 5, yeah, 5 minus, or let me do, yeah, 5 minus maybe 3i all over 1 plus say 4i. Okay, try to do this one. All you are doing is multiplication. You know how to open brackets. There's nothing big here. How do you open brackets? You are multiplying by the conjugate, and the conjugate of the numerator, sorry, the denominator is 1 minus 4i, and you are doing the same thing here, 1 minus 4i. Okay, so what are you trying to do is multiplication. This first one will multiply these two, and this first one will do the same. It's the same thing that happened. I know it's the denominator that is giving you issue, but it's the same thing. If that is better for you, do it the same way. But we are just trying to make it shorter for you. Instead of opening this numerator, denominator, just pick this one and square it. Minus, pick the second one and square it. That's all. So try it, and let me see what you got. Okay, try it, and then when you are done, I may come back for binomial theorem like Dave. So this is Dave that asked that when a term that is independent of x. Okay, yeah, I may come back for that. Then try to get this division. Let me see what you have. Okay, okay, and then what's her name? Joel is asking for series and sequence. She too likes series and sequence. You too like series and sequence. Why? Since this semester, she has been fighting with series and sequence. Only a whole semester. Okay, let me see what you have with this. But sincerely, I need to rest. The YouTube people and their network by almost 2 hours. Sorry about that. Everybody, sorry about that. But at least it's even better that we use the video that you can see my face, because the one I wanted to use, my face would have, I would have tried using webcam. I mean, what do you call it? Screen, this thing, you always see my face.
Minus 7 minus 23.
Who is that? I even wanted to call your name, Chibebi. I wanted you to respond so that I'll be sure that this confusion has cleared. Who is the other person that said that she was confused too? Mention Valerie. Is she still online?
Yes.
Shebi, that's how to pronounce it. Valerie. Va. Are you still there? Let me see your own response. What do you have?
So I don't understand the binomial one.
No, we will come back there. We have not gone there. The binomial of that one of independent of x, abi?
Which is equal to 1 minus 20.
What's the value that Chidinma got?
Minus 7 minus 23i
All over 17. Which is got what?
1 minus 23i over 17.
1 minus 23i over 17. So they have something in common. Maybe just sign that is the problem. Okay. Okay, so it's just the sign that is the problem. Alright, so I'm going to do this now. Remember we said that it's till dawn marathon. So the marathon is going to end for now. So we wake up again by what's the time again now? 11:20. So we wake up around there. But you can still be sending questions maybe on WhatsApp, and I can be solving on paper and be sending. But we may go live again early in the morning, maybe around 3 or 4. I will wake all of you up. So we will refresh and then do that binomial and do some exam related questions, and then you go and brush and come and meet me here. Then you know I need to rest more. Tomorrow is going to be a long day. Okay, so let's do this together before we have a break. It's going to be a break. But set your alarm. You wake up. I'll join you. I'll set up our system maybe by that kind 4 or 3, and then we just maybe 1 hour or so. You go and prepare for the exam. Okay, so let's do that. Which other area did I not on? Series and sequence and
Minus 7. Okay, minus 3i.
okay, this is the first one. The first one. Okay. Like she said, series and sequence. And in fact, I have some important series and sequence questions I want us to see here. I've touched indices, I've touched logarithm, I've touched surds, I've touched numbers, types of numbers, we've touched sets. Okay, then maybe by tomorrow we'll still see some maybe 1 or 2 examples to different. Okay, we'll touch it tomorrow morning. Tomorrow morning, wake up. Set here. Okay, it has entered, Abby. Have we entered tomorrow? We are still today. Okay, tomorrow is coming very soon. Alright, so tomorrow morning by 3:30. So we just rest like 3 hours. Or you can even continue, you can stay awake and continue reading. But me, I will have to rest a little, then I'll join you later. Okay, so let's see this together. Okay, so let's do that, but let me try to do it here because of. All right. So what I'm going to have, remember what I said, 5 will multiply 1 to give us 5. 5 will multiply minus 4 to give us minus 20i. We are done with 5. Then you come over to minus 3i. Minus 3i times 1 will give us minus 3i. And minus 3i times minus 4 will give us 12 plus 12. Minus times minus is plus. 3 times 3 is 12. I times I is I squared. Beautiful. And that is all over. That is all over. Okay, so the denominator. Now remember what I said. Just pick the first one and square it. Minus, pick the second one and square it. That's all. So you don't waste your time. Even if you open it the same way you open the numerator, you still get the same thing. The ones in between will cancel out. So I hope you get it. That's what we are doing here. Don't waste your time expanding the denominator. They are conjugates. Okay? Alright? So let's start go. So you know that this one is minus 1. I is minus 1. So that's going to give us 5 minus 20 minus 3 will be minus 23i. Minus 1, which is your I squared, times 12 will be minus 12. And that is all over. Here will be 1. Then you have minus. Then 4 squared is 16. I squared is minus 1. So that minus 1 will multiply your 16. And so finally, you will now have the ones that don't have I, you join them together. 5 minus 12 is minus 7. Okay, you have seen the answer already. Then minus 23 I all over. Then this one minus 16 times minus 1 is plus 16. So 1 plus 16 will now be 17. Okay, so Chibaby, it's beautiful that you got it, right? So that means the second person should check, make the correction before you sleep. All right. So this is where I want us to pause. We are not ending the class, so we are just pausing. Then we'll go offline and then reconvene around 3, 4, depending on when the lecture leaves me. Okay. So 3, 4, we'll reconvene. Whether 1 hour, 1 hour 30 minutes, we'll touch those areas. Somebody mentioned set, somebody mentioned binomial theorem, somebody mentioned sequences. Okay, somebody is mentioning permutation and combination. I'll bring, there are some key areas I already mentioned in the physical class under permutation, those key areas. So there are other key areas that we still touch in those permutations. All right, so see you later tomorrow. Have a very nice rest and then good study as you prepare for this exam. Success. Of course, we'll be together tomorrow. So anyway, so see you later tomorrow. Bye. So meanwhile, give thumbs up. I see what you people have done. Thank you very much. I saw the subscription. I saw the likes that you gave to even the failed videos. I saw about 8 something likes to one of the videos that we didn't continue. That's very beautiful. Continue that with this one. Share this one also to your groups. Immediately we end, make comments, please. It's very important. That's at the end of the video. Your thank you, everything. Bring it at the end of the video when I close it. All right. See you later, dear friends. Bye. Chidika mmadụ ihe m ga-emere gị n'ụwa. Ka ihe m ga-emere gị n'ụwa.